Hi everyone, this is the lesson for circular functions for Trig 3.3. Okay, so if you don't know how to cut and fold and do all that fancy stuff, we can do it in class and I'll show you. But you cut the top out and you cut along those dotted lines, and then it folded like on those solid lines to make this, and then the bottom half folded in half to make the other one. Okay, so what we're learning about today is circular functions. So the stuff that we had already known from the other chapter was trig functions. So let's review what trig functions are and then introduce the definition to circular. So trig functions are when we have our domain in degrees. So all of our like x values are degrees, and then our range is the real numbers. So that's like the 1/2 and √3/2 that we get out from our equations. So we could have an equation. So an example of a trig function would be the sine of 30 equaling 1/2. So our input was 30 degrees and we got out 1/2. So the domain is our input angles. So we had degrees and we got out a real number, 1/2. Okay, so now let's take it over to circular functions. So for circular functions, it says that the domain is in radians and the range is real numbers. So now instead of using degrees, we're going to use radians. So that would be like having the sine of pi/6. Pi/6 is equivalent to 30, so that means that the sine of pi/6 is 1/2. Okay, so when we have degrees, we call it just a trig function. When it's in radians, we call it a circular function. And that's because the radians are based off of a circle, which is where our unit circle comes from. Okay, so they're called circular functions because what I just said, I don't know why I'm reading it to you. So we use s when we're talking about circular functions most of the time instead of theta, but it's just a different variable. It really means the same thing. So if you see like sine of s, that means our answers are in radians instead of degrees. So this is just a review of like how we use our unit circle. Remember, x is y, or x is cosine and y is sine. So if that is true, then the sine of s would be equal to y. Cosine would be equal to x. And tangent, remember we talked about, is the y over the x value. So to find the other ones, we just flip those over. So we have 1 over y, 1 over x, and x over y. Okay, so those are the definitions to help you figure out values for your unit circles. So on your unit circle, which we're going to, well, maybe we've already completed this at this point, but it's like your paper plate that we made. I'm sorry, I don't know why I'm strobing like that. Okay, so I'm sorry if it's strobing on your screen too. I hope it stops so you don't go blind or something. Okay, so here's our unit circle and our angle measures that we worked on in class on our plate, and here's their equivalent values in radians. So then we have their ordered pairs. So this is like the cosine at 30 and this is the sine at 30, and it goes all the way around. So hopefully at this point we've already talked about how the patterns exist and all of that stuff. So let's take a look at our examples. So it says to find the exact circular function value for sine of -3 pi. So if we take a look on our unit circle, we know that pi is half a rotation and 2 pi is a full rotation. So if we're going negative, we would go -pi, -2 pi, -3 pi. So -3 pi is equivalent to the sine of pi. And if we added 2 pi twice, we would end up with that. So that's like the coterminal angles. Okay, so what's the sine value at pi? Well, remember the trick, sine is the y-coordinate, so that would just equal 0. So remember, pi is 180, so the sine of 180 is 0. So those are equivalent. Okay, so let's look at number 2. Cosine of 7 pi over 4. So 7 pi over 4 is in quadrant 4. So the cosine value is the x-coordinate. So this would just be equal to root 2 over 2. So if you're able to do these using a unit circle, this is what you would do. You would just look on the unit circle and find your angle measures. Last section in 3.1, we did these problems, but you had to draw the triangles to find them, like what we did back in chapter 2. Okay, so secant of 2 pi. Well, I know that secant is really the reciprocal of cosine. So if I reciprocal that, I get 1 over the cosine of 2 pi. So now I'm going to have 1 over, and then the cosine of 2 pi. 2 pi is right here. Cosine is 1. So the cosine of 2 pi is 1. So the secant of 2 pi is 1. Okay, so why don't you go ahead and pause and try those last 2 examples, and when you come back, I will show you the answers. Okay, so the cosine of 2 pi over 3 is negative 1/2. And then the negative 9 over 4 pi. One thing that you could do is find the coterminal angle for that and then look at it that way instead of trying to figure out with negatives. There is another way to do it too, which is the way that I did, and I'll show you that in a second. But to find the coterminal angle, we would have our fraction and we would add 2 pi to it. Since it's still negative, I'm going to do it again. So negative 9 pi over 4 is equal to 7 pi over 4. So you can look for that on your unit circle. The way to keep it this way is just to count by fourths on your unit circle, which is kind of what we talked about when we made our unit circles on our plates. So this is negative 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, and 9/4. So 9/4, like I said, is equivalent to 7 pi over 4. Okay, so the tangent value is equal to the y value divided by the x value, so that'd be negative root 2 over 2 divided by root 2 over 2. So when you divide something by itself, you get 1. So that's where our negative 1 came from. Okay, so let's take a look at our next set of examples, and those are approximating the circular function value, which means we're going to use our calculator. So when you're doing it on your calculator, you have to make sure you're in the right mode. So everything we've done before was always in degrees. So now we're in radians. So we would have to change the mode on our calculator. So using these kind of calculators, you hit shift and then go to the mode, and then radians is number 4. If you can't figure out how to do it on your calculator, I can help you in class. Just make sure you ask me. So now we're doing the sine of 3.42. So we just type it in just like it says. So this is equal to negative 0.2748. So we're still going to round to 4 decimal places. So our same rules that we used before still apply. So if we have secant, we would need to do the reciprocal of it to get cosine. So 1 over the cosine of 5.6041, and that's what you would type in. So 1 divided by cosine 5.6041, and we get out 1.2851. Okay, so please pause your video and do questions 3 and 4. Okay, so question 3, we just typed it in exactly as it said. Question 4, we had to reciprocal it. But again, our calculator had to be in radians. Okay, so let's take a look at our last 2 examples. And these are problems where we're working backwards and we're finding angle measures. Okay, so it says sine of s is equal to 0.3210. So since it says S, that means we're in radians. They told us S is between 0 and 2 pi. So what quadrant is 0 to 2 pi? Or to, not 2 pi, pi over 2. So pi over 2 is equivalent to 90, so that's from 0 to 90 degrees, so that's quadrant 1. So 9 pi over 2, or pi over 2 is in quadrant 1. So that means we need to make sure that our answer we get is in quadrant 1, from 0 to pi over 2. So since we have an approximation here, we're going to end up with an approximation. So to check and make sure it's right, we need to know what pi over 2 is equal to. So I'm just going to type it in my calculator. So pi over 2 is approximately 1.57. So whatever answer we get from solving this should be between 0 and 1.57. So to solve this, we just do what we did on the other ones and use the inverse of sine. So S would equal sine inverse of 0.3210. And we'll type that in our calculator. And we get out that S is equal to 0.3268. So I would just check and make sure your answer is in the right quadrant, or you would have to figure out where it should be located. Because remember, sine is positive in quadrant 2, so I could have said this is in quadrant 2, but then you'd have to find the angle to get you to quadrant 2, and that would have been your reference angle. But since we're in quadrant 1, we're good. Okay, so let's take a look at number 2. So this one is between 3 pi over 2 and 2 pi. So what quadrant is that? Very good, quadrant 4. So since they're giving us it as the radicals, so that means we're wanting an exact answer, like with the fractions and radians. Taylor, you can't take that with you. Okay, so we will draw our triangle in quadrant 4. One thing about this problem though is if it's the root 3 over 3, we would need to like unrationalize it. So this is equivalent to 1 over root 3. And I know this was negative, so we'd have negative 1 over root 3. So the tangent of that is negative 1, adjacent, opposite over adjacent. So that means that's our hypotenuse. So our reference angle for there would be 30. So that means to get to quadrant 4, 360 minus 30 is 330. So our answer for S would be 330 degrees, but we want it in radians. So we would have to multiply by pi over 180 to convert to radians. So we end up with 11 pi over 6. Okay, very good. So if you have any questions, make sure you write them down so you remember to ask me in class tomorrow. Werner out.